All right, so let's proceed with results from working group session. So if you recall, yesterday we had 3 wonderful working groups, 3 panel sessions on drones, on 3D imagery, and GeoAI. So those were the general headings that we discussed. So what we're going to do in this session is come back. We'll have a short synopsis of the results of those working groups, and then we'll take it further and we'll discuss a number of other items that came up, along with some of the resources that could help us as educators in each of those areas. And the moderator for this session is going to be Kansarina Cornier, solution engineer on the education team and a friend. Rina?
Thank you, Jerry. Thank you, Jerry. Hello, everyone. Yesterday, we had such a great discussion in each working group. Lots of sharing experience, knowledge, ideas, challenges, and of course, opportunities as well. We also talk about the trends in technologies. So very exciting sessions. We want to thank you all the panelists. And also we got a lot of questions. Thank you for all of you that participating. So what we are going to do in this session is we will present the result or the summary result of each working group and led by our academic leads. So I would like to welcome back Dr. Margaret Madden, Dr. Tommy Jordan, and also Dr. Charlotte O'Neill-Dunn. Thank you so much for being the academic leads for the working group and also present the result. Without further ado, let's start for the first working group topic, drones in education, challenges implementing IRSES technology. And with that, I would like to invite Charlotte O'Neill-Dunn.
Right. Well, one of the things we clearly heard yesterday is that people wanted to see more farm animals in this conference. And so I'm really happy to introduce everyone to Thumbelina here. It's hard to top Joseph in his beautiful musical renditions yesterday, but I'm going to try with the presence of Thumbelina. So Joseph, this is me throwing down my card. Well, great. Well, thanks everyone. And I'm going to go ahead and share my screen here and quickly talk through the lessons and concerns that we heard from yesterday's session. So how are we looking there? Hopefully seeing the screen. And so one of the things that was clear is that people are really struggling to get support for their drone programs in education. So there's a definite need within universities to manage that bureaucracy so that you can find those people who will champion that program. It's not just starting up a new GIS course. It really is much more involved due to everything from risk management to insurance. Partnerships are key on that, and I think we heard some strategies for how to do those, figuring out who on campus you can help by perhaps going out and flying a specific area. Maybe it's a construction site or a building, any of those types of activities that you can do. Folks are struggling with these sort of end-to-end workflow type things. And I think the exciting thing with the new software is that we finally have some solutions that will take you through everything from flight planning to approval, all the way through to the processing and moving things to the cloud. We heard concerns about software, specifically the number of software packages we need to use, the fact that those software packages are cumbersome on the desktop. And so we saw some great examples of how things like SiteScan are moving things into the cloud. So we're not just sitting around waiting for the photogrammetric processing. I think there's also a recognition that we can keep things simple, and doing things simple with low-cost drones and really taking advantage of their strengths, specifically the spatial resolution and the temporal resolution. And we don't need to get wrapped up with running perhaps cutting-edge LiDAR sensors or hyperspectral sensors or even multispectral sensors. We've got to help our students understand the unique role that drones play and the advantages that they offer compared to some of the other platforms out there. And then finally, a strong desire, I think, to share knowledge and lessons learned. And so Lane and I will be working on an Esri blog post together that we hope will provide some insights into how to kickstart your drone program and to deal with some of these issues.
Thank you. Thank you, Charlotte. That's an excellent summary. I agree as well. It's a lot of the challenges that some of them easy, but some of this is kind of like difficult to overcome. But I think through the experience, come advice, best practices, especially for those that just started, want to plan to offer the drone training. So I have a question in here. I see that some programs that only offer drone pilot course. Okay, how important do you think to include actually GIS or geospatial topics or skills into these drone classes?
I think it's absolutely crucial, right? When we think about why are we flying the drone in the first place, we need to keep in mind that if we don't turn those data into useful information, what's the purpose of going out there? And it's no secret that we need to have qualified and experienced pilots, especially when we're operating in challenging situations. But I think we do a disservice by just divorcing the flight operations from the downstream data workflows.
Yeah, I completely agree with that. That is very important that, and not only that you know how to fly it, but also it's equally important that how to process it to become the information product, right? So the other question that I have in mind, you see that it's a lot of programs offering now the drone pilot and drone processing. Do you think it has been saturated, the offer in United States, or the demand still higher for the supply of this skill?
Yeah, I think on some level it is saturated. If we look at sort of the number of Part 107 preparatory courses out there, I think what's not saturated and what's lacking are courses and programs that really integrate drone technology with the specific domain application. One of my least successful projects was very, very early on in our drone operations, where we went out and did a bridge inspection. And what we did was we just unloaded massive amounts of data on the bridge inspectors. And what they came back to us and said, you know, when we did a bridge inspection 5 years ago, we filled out the sheet of paper. You've given us a point cloud, you've given us all these images. We have no idea what to do with all these data. And it made me realize that I'm not a bridge inspector, and that the people who need to do that type of work need to have a whole host of skills. And flying the drone and processing the drone data may not be the most difficult skills to develop. It's some of those ones that are domain expertise. So I think the best thing that we can do is integrate drone technology into our civil engineering programs, into our environmental science programs, and into our historical preservation programs, where we can couple the technology with the specific applications.
I completely agree with you, Charles. Tommy and Margaret, do you want to add into that?
So we do integrate some, sometimes it's just a drone demonstration. Sometimes it's lectures, sometimes using imagery that maybe Tommy already acquired of an interesting place, like coastal marshes in Georgia, looking at soil erosion after hurricanes, looking at archaeological sites. So I'm stealing your thunder, Tommy. You might want to talk about that. But there's a lot of interest in a variety of classes that we teach.
Yeah, well, you know, and it's we've always believed in all the work that we've done at UGA, and it's easier to teach someone how to interpret a photograph or how to fly a drone than to teach them domain knowledge. And we did, one of the things that we've done at UGA is I think we mapped, I think it was 28 national parks, the vegetation, very, very detailed vegetation from aerial photographs. And there's no way, I'm really good with aerial photographs, right? Okay, I'm a certified photogrammetrist, all that stuff. I know nothing about vegetation. I could never have done that. I could manage the GIS, I'm good with that, but we had botanists. We taught them how to, they knew what they were looking at on the ground. We taught them what it looked like on the aerial photographs. They did the mapping. It's much easier to have a domain expert and teach them the skills they need, you know, to do the work. I did a roof inspection, Jarlath, with a drone, and I kind of knew what I was looking at. But again, I threw a bunch of photographs at the actual roof inspectors, and they said, "Huh, I think we're going to climb up there and see what we're going to look at." So it's, again, the domain knowledge is more important, but you still have to be able to have some skills for flying these things, because there's different ways to do it.
Skill in flying the drone and also domain knowledge, that's really good package. Awesome. Thank you so much, George, and Tommy and Margaret for the first group, working group summary on that. Very good point. Now we're going to move on to the result of the second working groups on the topic of remote sensing, the foundation of 3D capture and reality mapping. For that, I would like to invite Dr. Tommy Jordan.
Okay, well, I'm going to share my screen. I've got a few slides too here. Let's see if I can make it work.
Please do. We can see that. All you need to just play.
Is it working?
Play it from this.
There it goes.
Slide, please. Yes.
Okay.
Awesome.
So the panel we had yesterday included Caroline Tyra and Lee Brenton as kind of the Esri experts. Kira Morris was an outstanding moderator. Today, our moderator is Kanserina Kerna, who you've been listening to and seeing. We had a few takeaways that from the session that I want to just kind of run through. The poll results, data sources, 3D base maps, reality maps, and digital twins. And I tell you, some of this stuff was new to me. I'd never heard of a digital twin before, and I thought it was really cool. Poll results, we asked what was the value of having your data in 3D, and more people said for bedrock visualization, improved decision making. It's cool was the cool answer, but it actually fits pretty much every situation. But and then the data sources, people were using kind of the instant or the already 3D data, LiDAR and DEMs, more so than actually generating their 3D data from drones or aerial photography. And that's probably not that surprising. One of the things, one of the things that about the data sources, that most were using the data sources are LiDAR and DEMs, followed by drones and aerial photographs. But in the conversation, it came out that really the data source selection depends on the scale and the application that you need, that you're using this for. And then what is actually the final product? What are you trying to, what information are you trying to get? And from that comes, well, what data do we need to use? And really, no matter what the client says, more detail adds cost, but it's not always needed. Now, I guess if the client wants to pay for it, we can spend the time in the computing costs and generating more aerial photographs, but it's not always a win-win situation. 3D base maps was something new to me yesterday too, although it makes perfect sense. This is a product that is available from Esri, and it can be used to author and maintain a 3D base map for your organization. And the actual tool provides a series of workflows that can streamline the creation and maintenance of a 3D base map so that you can support diverse information needs. Although it comes with canned data, it also allows you to plug in your own data so that you can use it in your own situation. You can use the canned data to learn how to do it, see what the possibilities are and what the capabilities are, and then plug in your own data to fill in the blanks. And it makes it more it just makes it more personal, I guess. And also then you can use it, because you can't really use canned data to manage your city or your campus or whatever it is. Reality maps. This is cool. Now this is something I've really always been interested in. I've because of my drone experience, because of my aerial photographs and my photogrammetry and whatnot. But it's really going to the next level. This is something that Peter Becker talked about a few minutes ago. But within the Esri, what they're calling the Esri ecosystem, now there are some tools that can take you pretty much from start to finish on here. We're starting with flight planning, with site scan, drone to map for using drone images, and ortho mapping for using conventional aerial photography. And then you can throw the whole thing into this new product that is just going to come online soon by a company out of, I think they're from Stuttgart, they're from Germany, called N-Frames, and the product is called Sure. And I've been watching these guys for a couple of years, and when their product create these 3D meshes like you're seeing in that image there are just spectacular. They're really, really good. And what that can lead you to is digital twins, where we have a virtual representation of the free world. I mean, of the free world, of the real world, including physical objects, processes, relationships, and behaviors. And the GIS provides the foundation. We have the 3D information on top of it, but then you've also got all of the other information that underlies that, which creates a much more rich information environment. It can also represent present, past, or future conditions, which makes me happy since I do a lot with cultural GIS and historical sites and whatnot. Somebody asked yesterday if you can have a digital twin of a farm. And well, I haven't done a farm, but what we did do is we did point clouds of a collard green garden. So these collards are very popular in the South. They're hardy, and they have big leafy greens on them. And so this is a point cloud, which would lead to, I guess, a digital twin of a collard garden. And by extension, we could do that to a farm to monitor yield and production and throw in these things. If we were to do this we've also had a product where we were making these gardens, making images of the gardens, 3D models throughout the growing season, which leads you then to being able to have yield models and productivity models. The problem, though, is registering these 3D data sets. And I think that this is an ongoing issue that we've got. How do you register with precision these 3D data sets for multi-temporal studies in such a way that the error or the differences that you measure are actually true differences and not just misregistration errors? And that's not something we talked about, but that's something I think about a lot. Finally, there are a series of resources, and Kanserina put them up in her blog. She's also going to copy them to the chat box, and about the digital twin and 3D maps, 3D base maps, ArcGIS Urban, and then some information about the N-Frames and Sure material. And it's very interesting. And Kanserina, when you put it up there, I hope everyone will be sure to copy it and save it so they can look it up later.
Thank you, Tommy. I did put it in the chat for everyone. Feel free to open that. Great points all. It's interesting how the remote sensing 3D and reality mapping are now integrated, and having them all in one technology platform has really helped. Okay. I'm glad you mentioned. Yeah, I'm glad you also mentioned about the Sure surface reality. Again, yeah, we acquired it, Esri acquired it on 2020. The Stuttgart teams are now Esri R&D office, and we are very exciting, and we have more news in 2021. Okay. Before I move to the last working group, I have a question to you. How do you see this integration incorporated more in teaching and research? What important other than impressive visualization and look cool?
Well, you know, a lot of what we're doing is just, you know, how much time do we have? That's the biggest deal. The semesters are short. Attention spans are not so long either. But the biggest deal we're going to have is how do we go past the point cloud? How do we turn that point cloud into information? You know, we talk about decision-making process as being, you know, data into data into information into decision-making or something like that. And that's the hard part. How do you convert these point clouds and these beautiful images that you create into actionable intelligence or decision-making thing? And I think that's what we need to work on more. And the advanced students get it. But usually if they're working on it for, their thesis or their dissertation, they have time to actually go to that point. But I'm not sure that everybody does get that.
Very good points. We all agree with that. Thank you so much, Tommy. Last but not least, we're going to move to the third discussion group with the topic on GeoAI, recognizing opportunities and challenges, utilizing GeoAI for education. For that, I would like to invite Dr. Margaret Madden.
Okay, thank you. Just get my presentation up here.
Awesome.
They look good? Okay. So we had our Geo AI working group members here. Mansoor Rayad was the moderator. Myself, Omar Meher, Greg Brenner, and David Yu. So there were some questions in the chat that gave me the idea that people are really still a little bit confused about what Geo AI is. So I found this really good quote from Jay Theodore. And I was at the Esri Developer Summit this year. So geospatial AI, artificial intelligence, applies spatial machine learning and deep learning techniques to help solve complex problems and derive deeper insights in powerful and innovative ways. So very conceptually, but also it expands the power of GIS to support human in the loop and autonomous systems. So I really like that part because I always like to bring the person, their experience, their knowledge into any kind of image analysis. And then a little bit further, machine learning is using data-driven algorithms to learn something from the data, and you have to put that data in for training and also for validating the models. So you can see that the samples or the input data sets are extremely important. And then deep learning would be a subset of machine learning, using deep in quotes, which is really a layered neural network algorithms, and that's inspired by our neural connections that are in our human brains. So going over our poll results, we had 130 responses. So are you teaching a program that implements the GeoAI techniques? And just under 20% said yes, 30% are planning it, but over 50% no. So there's potential there. There's, we need to find out what is the barrier, what are the barriers to that, and how can that be helped if there's interest and people would like to do it. And for those who are implementing GeoAI, what level of students do you teach? And I was surprised. I thought it would be mainly graduate students, but really split graduate and undergraduate students. And then a big group of other. So I would be interested in knowing what the other students are in that category. And then what does your GeoAI focus on? Kind of as expected for me, that classification would be the main use, but then also feature extraction followed by predictions, and then a pretty hefty other category. Again, that'd be interesting to know what that is. And then what type of data are you using for teaching and research in GeoAI? Aerial imagery, so high resolution imagery, that makes me think. And then also LiDAR and vector data, and to a lesser extent the bathymetry, and no video at all. So some potential growth in those areas. Then, so in our discussion, we all agreed that there was a lot of excitement and interest in GeoAI, but need for training both of the educators and then the students in academia. And we all liked Mansoor's quote, "These days we are data janitors, cleaning and preparing data." So since these are data-driven algorithms, there's a lot of work on the data management side. And then although challenging, we do need to commit to think about working with arrays and matrices, which may be new to students, using maybe Python or some other programming languages. And this would be especially true in advanced courses when they would really like to branch out and do their own independent work. Some other challenges is assembling and labeling those training and validation data. That remains a challenge. It is critical to the success of the machine learning and deep learning models. And then there could be some barriers with infrastructure and computational needs. So there are a number of responses to that, and I was really glad to learn about the deep learning packages that are available in the Living Atlas. So the training sets are already created, and they can be used for a number of different applications are provided, for building. We saw some demonstrations about that, the building footprints, it's things like shipwrecks, and then also classification of different types of features. And then once maybe student and educators get used to that, then they could be customized with your own local imagery data. And I always like to bring my lessons and exercises back to places where the students are familiar. So I have them work with campus imagery, or I say, what's your favorite place in the world, or where's your hometown? So really bringing it back to places that they know. And then there are a lot of Esri cloud-based processing capabilities that are coming on all along, some in the future, but ArcGIS API for Python is there, ArcGIS Learn, and then ArcGIS notebooks. So we've already got the notebook environment, ArcPy, you're able to access all the geospatial processing tools. And then if educators or students are already familiar with other frameworks, the scikit-learn or TensorFlow, R, Jupyter notebook, you can also integrate with those. So a number of different options. So pulling just a few things out of the Q&A, one was that the AI ML still seems like smoke and mirrors. Some of the AI explanations are still confusing. How is it different from spatial analysis and modeling? And then are there training and teaching materials available at Esri that educators can use, examples and some galleries? So it's great to see that Kansarina did post the blog that was already mentioned. So a lot of resources here online, and click on the section for Working Group 3 for the Geo AI resources, and there's a number of different links, and I'm really looking forward to diving into these a little bit more. And then just finally leaving with a couple of the hard questions, and these are more advanced users who have found some issues with version differences, maybe between the ArcGIS Learn module and the other packages that are integrated. And then an interesting question came from Dirk Tiede from University of Salzburg. Instead of applying frameworks from the computer vision community only, could GeoAI be extended to include our history of spatial reasoning and other geospatial knowledge, including prior knowledge about geographical conditions, etc., already in deep learning and prediction processes? So I think there's always going to be interest and I know Esri is very responsive when users have suggestions and points are raised. Great at responding to them and adding to your suite of capabilities. So I'll end there.
Thank you so much. Thank you so much, Margaret. It's really great to end it with such thoughts on that. Thank you. I believe with all the resources that we have, we can see growing more and more that teaching and research will adopt the GeoAI technology. This is all the time that we have. Thank you so much again for all the panelists, academic leads, all this inspiring for us in the educator community. And Jarla, thank you for bringing Thumbelina. That was a treat for us. I return it back to Jerry now.